Hello everyone. Welcome to SS Educare Teaching Learning channel. Thank you for all my subscribers. Those who still didn't subscribe, please subscribe and watch my videos. Your support is my strength. Let's go to our channel. Scientist of the day. This scientist was a Scottish-born American inventor. This scientist's mother was deaf and father was tutor for deaf people. This scientist in his young age did not like his compulsory curriculum at school. So he kept changing schools until his age 15. But anyhow completed his graduation. During his graduation, he started developing interest in researches. After his graduation, he also started his job as a tutor for deaf people, where he fell in love with his own student and got married. So while pursuing his career, he started researching on telegraph messages. So this telegraph messages he found out using a single wire. Simultaneously, Edison's work culminated in sending 4 messages over a single wire. So he thought to send more than 4 messages through a single wire, and he was successful in that also. He was successful in sending more than 4 messages, telegraph messages, over a single wire. But he was not satisfied with that. Then he transmitted those telegraphic messages, or I have to say harmonic telegraph messages, which had musical note, into human voice. And he called that instrument as telephone. Yes, the scientist for today is Alexander Graham Bell, who invented telephone. So now we people are very much popular with all technical, everybody, whoever is there in a very long distances, we could communicate easily with his invention. So thus scientist for today is Alexander Graham Bell. Welcome back. In our today's video, I will be starting up with Chapter 2, Class 10, ICSE Physics, Work, Power and Energy. In this Part A is work. So, let us go to the definition of work. What is work? Let me tell you an example. See, I have drawn an object which I have denoted with A, and I am applying force F. When I am applying force on any object, the object displaces or moves to a very short distance and changes its position, which is your B. So I am denoting the force as F and the object moving to a very short distance as S. So work done is equal to F, your force, into S, your shortest displacement. Shortest distance, which is your displacement. Now F, I have denoted it with arrow mark above, and S, your displacement, I have again denoted it with arrow mark. What does this arrow mark mean? Which means that force is a vector quantity and displacement is also a vector quantity. What is vector quantity? When any physical quantity is in accordance with direction, we call that quantity as vector quantity. So force, I am applying force on what direction? This direction. The object is moving in the same direction of force. As direction is considered, we call force and displacement as vector quantity. But I didn't denote work done with arrow mark, which means work done is a scalar quantity which does not take direction into consideration. So work done is force into displacement. Force, or I can say work done, is the dot product of force and displacement. Look at the picture. You can see an object where force of 50 Newton is applied on it and the object is displaced to 5 meter. So that is, the object is said to be, some amount of work is said to be done by the object. Yes. So thus work done is your scalar quantity. Next, what is the unit, SI unit of scalar work done? See, force as work done is equal to force and displacement. The unit of force is your Newton and the unit of displacement is your meter. So comprising this together, work done is your Newton meter, or in other words you can call it as a joule. This is your SI unit of work done. Next, CGS unit. CGS unit of work done is force can be represented as dyne and displacement can be represented as centimeter. So comprising these two, work done is equal to dyne centimeter, or you can call it as erg. Continuing with 1 joule definition. What is 1 joule? 1 joule of work done can be defined as when a force of 1 Newton is applied on an object, the object displaces 1 meter, the work done is said to be 1 joule. Next, second definition. What is 1 erg? When a force of 1 dyne is applied on an object, the object displaces 1 centimeter, you call that work done as 1 erg. Next, this is about the units of work done. Next, what if the body is not getting displaced even when force is applied on it? See, what if the body is not displaced? Look at the picture. You can see a man pushing the trolley. Yes, I have drawn that here. See, a man pushing the trolley in this direction. So, where is the man applying force? The man is applying force on the handle, this direction. The object is moving this direction. Force is applied here and the object is moving this side, displacing this side. Of course, actually, when a force is applied, the object has to move upwards, but the object is moving straight. So, the object is, what if the object is not getting displaced in direction with the force? It forms an angle in such case. See, this one, the force is acted this side and the object is moving this side. So, there will be an angle formed between force and displacement. So, it is represented by theta. Then, now the work done in accordance with angle will form work done is equal to F dot product S cos theta. Continuing with the examples, when the force and displacement are different, they form an angle. What if the angles formed are different in different cases? Let us see with an example. Look at the picture. You can see a man holding a suitcase with different angles formed between force and his displacement. Let's see in case 1. You can see if the angle formed between the force and displacement is 0, then you call that as positive work. What is happening there actually? Work done is equal to F into S cos theta. F into S cos, and the theta here is 0 because object is displaced in direction of the same force only. So F into S cos 0. There's no angle formed because the force and the displacement is in the same direction. So cos theta or the angle is 0 only. Thus cos 0 is 1. So F into S cos 0 is 1. You will get Fs only. So work done is equal to Fs only, which you call it as positive work done in case 1 in the picture. Continuing with case 2, look at the picture. You can see the man not displacing, the force applied and the man is moving, the displacement is in the opposite direction for the force. In such case, when the object is displacing in opposite direction to the force, the angle formed between them is 180 degree. Let's see, when the angle formed between force and displacement is 180 degrees, straight line. So force is in this direction and the object is displaced this direction. So both are opposite. Force is applied this direction and the object is displaced in the opposite direction. So both form a straight line. And what is the angle formed between them? 180 degree. Thus, in such case, the work done is said to be negative. How are we getting negative? Let's see. Work done is equal to F into S cos theta. Here F into S cos theta is 180 degree. Cos 180 is minus 1. So F into S minus 1 will become F S with a negative sign. That is, work done is equal to minus F into S, which you call it as negative work in case of case 2. Next is case 3 from the figure. Case 3, what if the force is applied in this direction and the object is moving in a straight line? What angle they form when force is perpendicular? Force is vertically falling, on the object like this, and the object is displaced in a straight line. They form an angle 90 degree. In such case, what is work done said to be? Let's see. If the angle formed between the force and the displacement is 90 degree, then work done is said to be 0. Let's see how 0 comes. W is equal to F into S cos theta. Here theta is 90 degree. What is cos 90? Cos 90 is 0. When this is 0, anything multiplied with this will also become 0. Therefore, work done is 0. So, 0 work is said to be done when force and your displacement is perpendicular to each other and they form an angle 90 degrees. Thus, work done is said to be 0. Summarizing all three cases, case 1 we have seen force and the object displaced is positive work done. Case 2, force and the object forms 180 degree and the object force and the object displaced is 180 degree. Work done is said to be negative work. And then third case, force and the object displaced forms 90 degree and the work done is said to be 0 work done. Continuing with one more example, I'll show you one more. See, and this is a man trying to throw stone up. So, force is applied on upward direction and the object is also displaced in upward direction. The force is also applied upward direction, object is also going upward direction. If both force and displacement is in the same direction, we already have discussed, the angle formed between them will be 0 and the work done is said to be positive work. So, the work done by the person is said to be positive. But there is one more force acting on this object. Not only the force by the man, there is one more force acting on the object. The particular force is gravitational force which tries to pull the object downwards. You can see the arrow mark in the opposite direction. One arrow mark is upwards and another arrow mark is downwards. Yes, so this is opposite force or gravitational force acting on the object and tries to pull the object downwards, which is opposite. So, the work done by the person is positive and work done due to gravitational force is said to be negative because they form this one, the object, displacement and the force is opposite and it forms a straight line, that is 180 degree. So the work done by due to gravitational force is said to be negative work, and the work done by the person is said to be positive. Next, one more example for much clear understanding. So I have taken an object on a surface, and the object, three different forces are acting on the object. F1, F2 and F3. Three different forces. F1 is an external force acting on the object, and there's one more force acting on the opposite direction which tries to stop the object. That is your frictional force. Then there is third force acting on the same object which tries to pull the object downwards. That is your gravitational force, that is your F3. Then what is work done said to be when three different forces acting on the object? How object will be displaced? Let's see. So work done due to external force F1 is equal to F into S cos theta. It forms what is that? Angle, which is your cos theta. So here, when the object force and the object moving is in the same direction, then cos theta is always 0. So cos theta is 0, we will have cos 0 is 1. So F into S, that is 1, is nothing but your Fs only. So work done is said to be F into S. So we call this as positive work when external force is applied on object. Next, second force which is trying to stop the object moving, that is your frictional force. So in case of Wf2, which is your frictional force, you can see F into S cos theta. So see, the object is this one. Object is moving in this direction, force is in the opposite direction. So it forms 180 degree. Yes? Okay. Cos 180 is minus 1. So F into S minus 1 is nothing but F minus of F into S. So your work done is said to be minus F into S. So this can be called as negative work done when the force and displacement is forming 180 degrees. Next, third one. Another force acting on the object which tries to pull the object downwards in the opposite direction. If you see, object is displaced in this direction, force is in this direction. So they form perpendicular angle. So the angle formed is 90 degree. So F3 is your gravitational force. F into S cos theta is your cos 90. Cos 90 is 0. So anything multiplied with 0 will also become 0. So work done is equal to 0, and it is 0 work in such case. So this is what is a very good example for work done with different angles. So there ends your introduction for work. So we have discussed the definition of work done, and then SI unit, CGS unit of work done. And what if the object is not displaced, or what if the force and object is displaced at different angles? What sort of work done is said to be done? We have seen all this in this video. In my next video, I will be discussing about power and energy. Thus, if you like my videos, please click like button and don't forget to subscribe my channel. Your support is my strength.